Kia ora, I'm back again. I'm going to tell you a little bit about analog to digital conversions. And the way I want to do that is just exhibit to you what's happening with an ADC. So with an ADC, when we're doing a conversion, we've got this linear value doing whatever it's doing. And then what we're doing, let me just get that out of the way. We've got some voltage, but what we're getting out of it is a stepped waveform. So this is our voltage resolution, right? Now, and the other thing, of course, our ADC can only do so many conversions per second. So we're actually only taking samples at certain points in time. And there's all sorts of nice theory about the fact that you need to take samples often enough, otherwise you'll miss what's going on. And I want to show you where I'm missing some stuff that's going on if my sampling rate isn't high enough. And to do that, I've got my two oscilloscopes here. I've got several oscilloscopes, but I'm going to use this little Espotec Labrador. And this is a cool little scope, $29 US, comes with some sweet software. And yeah, it's really nice for its value. It's actually got an 80 Mega X, which is another Atmel microcontroller there. And the other scope I've got, of course, is my analog discovery one from Digilant Inc. And that's a pretty high-tech device, a lot more expensive. Let me go Digilant Inc. Analog Discovery 2. And oh, look, they're $500. You know, that's not a cheap device, but we're going to see even the limitations of this. So this can sample at 100 megasamples per second, and the Espotec Labrador can sample at it's about 750 kilosamples per second from memory. I won't go into that. You can have a play and have a look with that. So, and of course, then there's plenty of other oscilloscopes you can have a play with as well. You know, I've got these little cheap hardware ones. This is not a bad one. And all these pulse width waveforms you can see on these scopes. Okay, I've got that one. I've got another couple up my sleeve as well, and they're all really useful, but they all have limitations based upon, and of course, what is it? It's the digitization, right, of this. So the range of, or the resolution and the sampling rate. So what I want to show you now is the difference between these two scopes, so you can see the difference in sampling rate. So let's just have a look at what is coming out of the Espotec Labrador. So let's have a look at this waveform. We'll just zoom in a bit on that. And you can see it's sort of jittering around a little bit. So let's just pause that and have a look. So here you can see the voltage resolution. You know, it's either, you know, triggering around sort of one value down here. So you can ignore this. This is not a signal. This is just the analog to digital converter flicking between two values, okay? And up here, what we've got is we've got a bit of a spike. Now, if I unpause that again, and we'll just go, you can see that that spike happens both on this rising edge and on the falling edge. Let's just pause that and see. Oh, there we go. We've got the spike a bit better there. So let's just zoom in on that and see what we've got. So let's just watch that again in live. Oops, come on. Just got to trigger. Let's just pull that into perspective. So there, this is what's happening, is that you can see that these spikes are occurring, and there is something there. We're not sure exactly what it is. We can't measure it, and the reason we can't really measure it is because of the sampling rate of this device. So if I freeze this, and let's pause that and see if, now you can see sometimes it's sampling it and sometimes it isn't. And it just depends on where it is in its sample cycle. Now, if I take my other oscilloscope, which is and the software for that is waveforms. So this is the analog discovery board, and I zoom in on one of these. Right. Now you can see that the spikes are there. Okay, I'll just turn off No, I'll zoom in. Let's just zoom in a bit more. Now you can see that's not actually a spike. What it is what's called ringing. And what's happening is that we've got, on our circuit board over here, we've got a pin of the microcontroller, which is connected to a pin of the board, which is connected to a breadboard, which is connected to a wire, which is connected to a resistor and a FET and the LEDs. And we're monitoring at this point where the wire is connected to the resistor. Now, so effectively what we've got is we've got an oscillator here made up of inductors and capacitors. And the reason we've got this inductance and capacitance is because we've got all these wires hanging around in a circuit board. And so this is like not just a wire, but it's actually an inductor and a resistor. So our wire actually looks a little bit like this, not like a wire, but actually a resistor and an inductor, and of course this in capacitance, because these things are next to other wires, and so we're getting actually a little oscillator is happening here. And every time we punch this oscillator with a waveform, like a change from 0 to 5 volts, it starts oscillating, and then it slowly stops oscillating down here. Now, you can't see that, of course, in this ESPOTEC circuit. You can see that something's happening, but you can't measure it, okay? And this is the limitation of our sample rate for an ADC. You're missing things that are there, okay? But if I go back to my waveform software, now I can zoom in a bit further. My software is more capable than the hardware here. So if I zoom in on this a bit more, you'll begin to see that actually what we're getting is we can actually see the samples that are being taken. So I'm just going to pause this, and you can see when each sample is taken. And then it's just extrapolating this frequency here. So we're getting a better understanding of the oscillations, the ringing that is happening in our circuit. So you need to know the limitations of the ADC you are using. Trying to measure a signal which has a higher frequency than what you are able to measure will just show you might think you've got a square wave there, but of course there isn't such a thing. What you have, of course, is this oscillations happening, and so this is the characteristic of the oscillation taking place, the ringing in each instance. So if I zoom that out, and now you can see what the developers of this software and hardware have done to try and fix that is that they sort of carry this averaging process over time, and it gives you this, oh, this won't stop fluffing around. We'll go over here. You can see that it's doing this sort of averaging over time, and it is giving you this fuzzy value here to say that there's actually more going on here than you can actually capture. So I'll just stop that again, and we'll zoom in. Let's zoom in on this negative edge, and again, there you go. So what you're seeing is the ringing. Oh, and here you can see the average sort of values that are taking place around this, that it's collected over a short period of time. So this is a better piece of equipment. Just be aware of, you get what you pay for when it comes to an oscilloscope. Of course, this ringing, what's causing it? These inductances and capacitances around this circuit here, even these wires. If you want to make a decent measurement, you're going to need a good scope probe and a nice test environment. So I hope that helps you understand a little bit about our sampling rate issues, and also you can see the steppedness of this waveform here as it's as it's doing its measurements. It's fluctuating. There's no actual change in voltage here. It's just the ADC voltage resolution slipping from one bit to the next. Okay. Hopefully that's of interest and helps you understand this a little bit more. Cheers.